to see. And when we talk about changing state here, it was the Klingons that were attacking the Enterprise, of course, and the Enterprise changes state. And if you remember, every time the Klingons attacked the Enterprise, the same thing happened. We had Captain Kirk sitting up here on the bridge, and after he got off the floor and all the dust settled around there, he would say the same thing to the IT person in the back, who was Scotty, and he would say to Scotty, damage report. And Scotty, of course, is sitting back here in the fantail, just like all the IT people sitting next to the furnace room, as always. Now, what did Scotty do? Now, this is a pretty advanced enterprise here, and what they actually did was to have a holographic blueprint, of the as-is state with all the holes in the enterprise, and the desired state, which was essentially the way the enterprise should function in the future or in the past. And they would build essentially a very quick plan, roadmap as to what to do. Hey, we got to fix this immediately. This can be delayed for a few minutes. This one isn't critical right now. And essentially the enterprise would work forward. Please remember that the concept of change that we're talking about here in architecture is really the key. When you have something that's complex, you got to write things down. And that's where enterprise architecture comes in, when there is complexity. When you're building a log cabin, you don't need much architecture. You're building a 100-story building, you got to have a lot of architecture. And you're not looking at building an architecture in 5,000 pages of text because you can't see what is going on. So I wanted to introduce a little bit of humor here, as we move forward. Now, I have to do one other thing here, and that's that we don't know all the people that are on the seminar with us this morning. So I have to do something here prior to getting started. And what I need to do, of course, is to put on my glasses here, and I have to get my neurolator and make sure that you look in the lens there. Now, for some of you, I have to do this again. Okay, now what was that silly thing about? One of the things about this topic is that with Facebook and Twitter and LinkedIn and Wikipedia and the internet and B2B and B2C and all these other things out there, there's a tremendous amount of confusion as to what this topic is. So the reason I had to bring a little neurulation in here is to, at least for the next hour, provide a new environment devoid of all of the noise that all of us see out there in this concept of enterprise architecture. And I want to begin, essentially, where all this began. And there's a lot of confusion about this topic. And the reason history is a little bit important right now is because if we don't look at history, we tend to make the same mistakes over and over again. And that's a little bit of what we're seeing right now. What do I mean mistakes? I'm not talking about catastrophic things, but we are actually in the second generation of these concepts of architecture right now. And if you look at some of the sources on the internet, they suggest that enterprise architecture and architecture in general of business began in the late 80s. Well, unfortunately, if you don't recognize where it actually started, we see the same mistakes over and over again. Now, as some of you can see here, my hair is graying a little bit as to what I have left. So I've been around for a couple of days here. And some of the things that I'm seeing right now, we've seen before in version 2. So when I was a programmer, I mean really doing actual programming, we had this concept of protocycling, which is now sort of referred to as agile programming. When I was doing programming back then, we had this concept, a revolutionary concept called time sharing, which has strong similarities to what we're seeing now in the cloud. Now, I can go on and suggest to you that some of the things that we've done in the past, we're doing over again under a new type of environment that's there. We used to look for building systems that were flexible. Now we're building systems that are agile. You can see that some of the words that are changing that's there. So this takes us back to 1966, just for a few minutes here. And the gentleman that I would suggest invented all of this stuff that we're trying to do here is a gentleman named Dewey Walker. And Dewey Walker worked for IBM for quite some time, and he began his activities in the late 60s, as you can see here. And he became the first manager of what was referred to as information systems architecture. Kind of fascinating. Of course, the domain of IBM was information systems. And in this capacity, oversaw the development of many important analysis tools. In 1970, as you can see here, he was commissioned to establish a national marketing approach. A national marketing approach, what does that have to do with architecture? Well, what IBM realized early on was that if they had a picture of you, the business person, the company, they could sell into that. And what they essentially did was provide a service in the 70s that would essentially go out to your organization and provide a blueprint of your organization, and they would be able to essentially market into that. And if you remember, essentially back then, the phrase was, if you buy from IBM, you never get fired. And that was because they knew a lot about your organization. And we're suggesting that really is the roots of what we're talking about here. And that was called business systems planning. The first recognition that planning is what you need prior to implementation. So it's kind of a fascinating situation back in the 70s. And what Dewey developed with his colleagues there was this concept of business systems planning. And what I have here is essentially one of the first publications in the area of architecture, which was a planning activity. This is a little bit yellowed over the years. And basically, this is the roots of what this was. Now, the colleagues that Dewey had at IBM, some of them are quite famous. One was John Zachman. Another was John Soa. Another was Clive Finkelstein. And another was Dr. James Martin. So he collaborated on this stuff for quite some years that's there. And I wanted to bring that perspective to you so that you could essentially see that we are essentially an iteration, and some people would say 2 or 3, but definitely there's history here of over 4 decades, 4 decades of work in this particular area. We began these particular activities in the early 70s. And if we contributed anything to the area at all, we would suggest it's an actually doing architecture. Our practice is about doing architecture and essentially providing the concepts of methodology and process to this particular area called enterprise architecture. I want to start off with a definition of this topic. You really need to look at this and see it as a definition. I wish I could say that everyone doing architecture agrees with this, but as I said, there's just so many people that are talking about this that it really is kind of difficult to figure out what is actually correct and what is incorrect. But for this session, I need to have a baseline definition so that you and I can essentially move forward based on what we see as enterprise architecture. So enterprise architecture, the first key phrase is explicit. And when I use the word explicit, what I say is that your enterprise, your business has an architecture, whether explicit or not. It's actually implicit. If you have built something underlying that, whether it's actually represented explicitly or not, is an architecture. And if you've got 17 people working on something, you have 17 essentially opinions of what that is. Unless you're Dr. Spock with the Vulcan mind meld, you're not going to be able to get that information out. So the key is that we have to get people to recognize that architecture is not about doing architecture, it's about making it explicit. And enterprise architecture is about making something explicit. And we suggest that at a minimum, 2 different pictures are required. The desired state, some people call it the future state, the to-be state, and the as-is state. Because in order to build a pathway, a map, you have to have essentially 2 points, where you are and where you want to be. Going further, how do we want to do this? With the minimum amount of effort involved. And we suggest that is the concept of independent, non-redundant artifacts. In other words, the things that we need is the minimum set of things to actually move our business forward. So we're looking for the minimum set of things that we can use to describe the desired state and the as-is state that's there. Now, we refer to those early on, remember the topic of this particular session we're having, as the architectural elements. Going on to the next phrase, We define how these artifacts relate to each other, which we call the implementation artifacts. And of course, we'll be getting into more of this as we spend some time together here. So we actually see that there's actually two sets of models required. Models of the architecture, what the thing should look like, and models of the implementation. Let me give you some analogies here. There are models that revolve around the engineering of the thing you're trying to build, and there are models around the manufacturing around these things that you're trying to build. Let me give you another set of analogies that's here. There are models that are built for human consumption, and there are models that are available for compiler consumption. In other words, the development of code. And we see this discipline outside of IT everywhere. There's actually two sets of interlocking representations, the architectural representations and the implementation composites. This is one of the keys to architecture. And one of the things that we've been driving home for decades now is there's not one set of models that the enterprise needs. There's actually two sets, the ones for architecture and the ones for implementation there. And then essentially developing a set of prioritized, aligned capabilities. Another phrase for capabilities could be initiatives. Another phrase for capabilities and initiatives could be focus areas. It's essentially getting projects out of this understanding that are aligned to meet the organizational goals that are there. So there's lots of terms that people use, and we're going to try to, in a short period of time here, tighten up on the vocabulary so that you and I can communicate. And this is one of the problems we see in enterprise architecture, is that there is an issue about communication. It is very, very difficult for people to get an understanding of the topic when people say, well, we're doing enterprise architecture, and there's 1,000 different definitions that are there. Okay. Now, we're not done with the definition. Now, we go on, and the next thing we have to talk about is communicating this understanding to stakeholders. Communicating this understanding to stakeholders. And one of the things about our Twitter, Facebook, online universe that we're in, we've had to, over the years, change the approach that we have for these types of communications, and now recognize that the tolerance of individual to a discussion or learning is about 1.5 minutes. Now, I know that sounds a little bit funny, but I'm being very serious about this. The methodology and the processes that we are using, that we suggest that you use for architecture, have to be demystified to the uninitiated in 1.5 minutes. That's not a joke. Now, that doesn't mean they know how to build these things, but they have to be able to understand them. It's the old elevator pitch. And that's one of the things we have to look at. So if you're doing enterprise architecture and you're building some things, keep that in mind, that that's essentially the tolerance that people have for these types of understanding, advancing the organization from its as-is state to its desired state. Please notice in this definition that there is no phrasing around technology. That's because we suggest enterprise architecture is about helping the business run better. And one of the things that we can do to help the business run better, of course, is to build information systems. But there's so much more that we can do with enterprise architecture to help the business run better well before we actually start building information systems. The other bit of confusion a little bit is what is an enterprise? And quite simply, the concept of the word enterprise is really a scoping statement. What I mean by that is it says anything within our definition, our bounds of the enterprise, we can essentially have a mechanism that we refer to as an integrated environment. Anything outside of that boundary condition we call the enterprise will be an interfaced situation. I'm not saying one is good and one is bad, but we have to recognize that that's true in the physical world in our daily lives, okay? There are things that are integrated, and there are things that are interfaced. And that's one of the things that we see about this concept of enterprise architecture. Whatever we define as our enterprise is the scope of what we can integrate. Other than that, we'll have to have interfacing going on. So it's obviously very important on how we define these things. The other thing we have to recognize is that if we have two pieces of our business that are architected, and if we try to mush them together, mush is a technical term, of course, we try to mush them together, it may not happen, even if they were both architected, because there's not an overarching architecture around all of them. So that's the other thing we need to recognize, is that whatever we define as the bounds of our architecture is essentially the integration approach. If we have something that is larger than that, we're going to have to consider a little scrap and rework, redoing that architecture to understand that new environment. Now, the word architecture has been around for a long time. It's an art and a science of building something. It's an art and a science of building something. I equals D over T, F equals MA, all these formulations is the science. The art is why one building looks different than the other, and it's the same thing here with architecture. There's experience that is gained, there is science that is gained, there is knowledge that is gained over time. And we're starting to get the codification of that knowledge, which is just fantastic, just fantastic. It hasn't been very long. There's been a lot of opinions, but not a lot of codification of what is going on. And I want to suggest to you that we, as far as we are concerned, are going through the natural evolution, as we see here, from past years. You and I are really change agents. What architecture is a change agent to take our enterprises from the industrial age and move them into the knowledge or information age. And we can see here, and of course this graphical representation isn't accurate, it's just depicting essentially the trends that are going on, is that we are facing essentially another movement from one age to another, and we happen to be the catalyst, the agents that are moving our enterprise from the industrial age to the knowledge age. Now, the organizational behavioralists that study this tell us that the transition from one age to another, fortunately or unfortunately, depending on how you look at it, is 40 years. 40 years, not 4, but 40 years. And there's essentially a change that goes on. There are people that are resisting this because, frankly, they are being displaced. So the industrial age skills are being replaced by information age skills, and those people in the industrial age aren't real happy about that. Just like in the agricultural age, when the mercantile age came around, and you had this, consolidation of how things are sold and shipped, the farmers weren't happy. The French peasants weren't happy. They were rioting in the streets, those types of things that were there. So we see this transition going on. And there are many, many, many characteristics, and I'm not going to go through all of these, to justify and have us understand essentially the big differences that are going on. I just want to point out 2 of them here that are quite important. One is the science. Mechanical engineering was the key in the industrial age. Computer science is the key in the information or knowledge age. But what we're talking about in the computer science is not programming skills, which are implementation, but understanding skills, the engineering skills that are equivalent in the knowledge age. And we are now seeing a few universities getting into essentially providing degree programs in, you ready for this, enterprise architecture that's there. And we're frankly proud and humble that these universities are actually using our courseware as the base for these bachelor and master degree programs that are there. And it's really kind of interesting to see this happen. The other thing that's changing is the basis of wealth. It used to be land, labor, and capital, physical assets. Now it is information. And that's why everybody tries to hoard their information. And I believe, don't tell anybody here, this is quiet, I believe that relatively soon, you and I are going to recognize that the people that are not paying us for our information, and you know who they are going to wake up one day and going to realize that they're going to have to pay us. Because information is the new currency that's there. If you want to know my profile, you're going to have to pay me 6 cents a view. If you want to know more about me, you may have to pay me 10 cents a view, that type of thing. We're going to get there. Remember this 40-year transition. So there's a tremendous amount of evidence that there is essentially this transformation going on. The old phrase that we used to use is a paradigm shift. I really think we have one as we're going on here. Now, what can we learn about this? It is about enterprise change. And I'm going to be a little bit direct because we only have a a little bit of time today with you and suggest to you that handcrafting programs, no matter how small they are not going to get us there. We got to get away from this concept of handcrafting programs because the enterprise is going to constantly change. One of the things we have to recognize about enterprise architecture is it never stops. Architecture stops when the enterprise dies. If the enterprise is going to change, the objective should be we architect and then we implement. We architect, then we implement. We don't implement and document. Wash my mouth out with soap if I use the term document to essentially describe architecture. It's not. It comes before the change is made, not after the change is made. And this comes from the understanding, once again, in the physical world. Now, I want to be very careful here. Not everything is transferable into the information age, but a lot of the things that we can see are there. So, for example, if you want to integrate your financial organization, I think most of you would believe that you can't buy 100 copies of Quicken and mush them all together and have an integrated financial system. Now, isn't that interesting? You can't do that. It's not about scalability. It's different. Architecting a 100-story building is very different than architecting a rancho. It's different skills, different understandings, different that's there. You can't take a log cabin and pile 100 log cabins on top of each other and get a 100-story building. There's a different set of things that are there. You can't essentially approach a 100-story building one floor at a time. You have to recognize that essentially the 100-story building is what we need to build. So what can we learn from all of this to help us in the complexities of enterprises? And I'm going to suggest to you that enterprises are probably more complex, and actually are more complex, than any physical thing that you and I or humankind has built in the past. That should tell us something. When things get complex, you got to write things down. When things get complex, you got to write things down. It sounds so simple. It's amazing. If you're building log cabins, you don't have to write a lot of things down. You need to write things down. You're building or changing a 100-story building. This is just fundamental blocking and tackling. So if you're talking about a corner grocery store, a one-off type of thing, you don't need much architecture. If you're talking about your enterprises, you need a lot of architecture. If you're building a balsa model with airplane, you may not have to write things down. If you need to write things down when you're building or changing a Boeing 747. And I'm thrilled. I am thrilled that Boeing and Airbus and all these other manufacturers have figured out how to change stuff, especially when I'm flying in that airplane at night over water. I'm very happy that somebody has figured this stuff out. And this is the thing which you have to understand. But, big but here, but what you write down and how you write it down and how you build it affects the ability to change something. Please notice the three phrases. What you write down, how you write it down. You have to get various people to understand it. There's not one picture here. If any of you have had the privilege, pleasure, or frustration in building a house, you know exactly what I'm talking about. When you're building a house, you don't get one drawing, 8.5 by 11. You get a scroll of drawings of something as simple as a house. You get the heating, ventilation, and air conditioning drawing. You get the plumbing drawing. You get the electrical drawing. And if you try to mush all those together, there's that technical term again, you can't see your house. So once again, from an enterprise perspective, we can see there's going to be multiple representations depending on what you're trying to show. The other thing I have here at the last end of the sentence is how you build things. How you build things. This is one of the important things. It's not just architecture, but it's how we develop the things that will allow it to be changed or not. So it's architecture plus a few other things that we'll talk about in just a moment. Architecture is about addressing complexity and change. And the last thing that we want to do is impose in our businesses complex things on top of the complexity. Architecture is about simplification. And that's one of the things that we have been doing now for decades, is trying to get the minimum set of things that we need to understand the enterprise. So we're not talking about a book that's 700 pages that has all sorts of options and opinions. It says, here's how we do this based on practice. Actually, thousands of engagements that say, here's the minimum set of things that we need to be able to do this. Oh, by the way, if there's something you'd like to have as optional, that's great. But if you don't do this, you're probably going to have an issue. As been said a lot of times, making things simple is actually hard. Making hard things harder is actually kind of easy. Flexibility, agility historically comes from two things: architecture and assemble-to-order manufacturing and implementation. And I'll be talking about that a little bit more. But I want to just give you a taste of this phrase here as we're moving forward. Architecture will describe an assemble-to-order manufacturing. This was one of the fascinating things that we discovered about flexibility and agility in the real world. And it turns out that you and I see this all the time. Now, I've been told when we give our seminars and our workshops that this was the best analogy that I've come up with. And I don't know if it's the best or not. But what we're trying to get our enterprises to recognize, and especially our development environment for solutions, is what we need is you ready for this? A salad bar. A salad bar. Not a bunch of pre-made salads that have essentially things put together. Just think about a salad bar for a moment. Let's say that on your salad bar you have iceberg lettuce, romaine lettuce, garbanzo beans, cherries, tomatoes, celery, and lettuce. Just think about all the combinations that you can implement based on those independent bins that are there. It's kind of a fascinating analogy. And what we have to figure out is how we do that in enterprises. And that's exactly how we see manufacturers of computer systems. How can they build us an almost custom product in a day? What do you think they have stored in their warehouse? Every conceivable variation? No, what they figured out in their domain are what the independent variables are, the minimum set of independent variables to allow you to have an almost custom product that's there. So the computer manufacturers have figured out we're going to separate disk drives from keyboards, from power supplies, from memory chips, those types of things that are going on. Those are what we need for assemble to order. If we go to Home Depot or Lowe's and we're building a house, we walk in there, what do we see in that environment? We see 2x4s separated from wallboard, separating from nails, separated from windows, separated from doors, separated from shingles, roofing shingles, separated from cement. All of those allow us to what, again, you notice that phrase, assemble to order. We have to figure out in our enterprises how to do this. Now, what we tend to do in enterprises is build composites. So let's go back to the salad bar for a moment. Usually sitting next to the salad bar is a bunch of pre-made salads. Now, what does that provide us? It provides us with a product very quickly. We get out of our car, we're always late for a meeting, we run into the store, we grab one of those pre-made salads, we pay for it, and we run out the door. Then we get back to our desk, and we unseal this, and we say, oh my God, look at this. There's radishes in here. I don't like radishes. And you pick those out. Green peppers, I can't stand green peppers, and you start picking those out. Now, what we're doing is disassembling what's going on. Now, if some yo-yo decided to put dressing on there on top of that, we've got a mess on our hands. And that's really what we have in our enterprises. We have composites that somebody said this should work. And if we have to take it apart again, we got to go back to square one. We need the concept of assemble to order, that salad bar component. Ladies and gentlemen, this is all around us. We have to architect and have assemble to order. It's kind of a fascinating thing if you look back in the decades that they've been doing this. It's difficult to believe that agility comes from handcrafting things smaller and faster. That was one of the beliefs that was there early on. It goes back to, as I mentioned to you, my early days of prototyping. We said, we're going to build these little modules, and it'll have functionality and data in it and everything else. We're going to mush them all together, and the world will be wonderful. Well, it didn't happen, because what we didn't recognize was architecture was different than implementation. Engineering was different than manufacturing. So it's not how small we make these things. When you walk into Home Depot, you don't see in the lumber department a bunch of toothpicks that you stack together to build a 2x4. That would be crazy. Notice how crazy it sounds. Same thing in enterprises. We're not talking about how small we make these things. It's figuring out what the independent variables are to allow us to assemble to order. So agile programming is not going to get us an agile enterprise. Agile enterprise comes to the ability to address complexity and change. And that comes through the recognition that there's two constituents that we have to understand: the engineering and the manufacturing, the architecture and the implementation, the client, the customer, and the implementers. Two audiences, two different people, two different groups that have a similar end game but need different representations. The architectural representation are different than the implementation representations. And if we study the world of physical change a little bit, we see that there's three ways to change a physical object. Now, why is this important to us? Once again, if we look at it, we see how we can essentially change our enterprise and enterprise systems. The first is go for it and see what happens. Please notice there's a smile on my face. Pretty dangerous approach. High risk, low reliability, change by trial and error. But to be brutally honest, if we have no baseline for managing change, architecture, this is the way it's going to go about. And we hear this all the time. This is a transparent change that won't affect the thing. The other approach is to throw it away and start all over again. And we hear this a lot too. Well, all we got to do is to throw it away and we're going to be all set. In the world of enterprises, that's awful hard to do. That's called bankruptcy generally. And this is a hard thing to see here. And in the physical world, we've learned about the concept of scrapping things because its useful life is exhausted. And that happens a lot. Or, of course, the other thing is called don't change it. Don't touch it one more time. If you touch it one more time, the world will come to an end, essentially, as we move forward. Now, the key to enterprise flexibility is called reverse engineer and change it. This is the key to changing physical objects. Please notice that I put the word reverse in quotes. Reverse in quotes. And that's because we can't reverse engineer something that wasn't engineered in the first place. And this is what we're seeing right now a little bit. And I just want to introduce this concept, and I can't go into it much at this time, is the issue we suggest with the concept of big data. We've been talking about data for a long time. It doesn't matter how much data you have. The prerequisite to that is, quote, good data. We can't take 27 customer databases that weren't defined with the same understanding and mush them all together because we're going to get a bunch of mush push. That's there. So it's not big data. First comes good data. And this is something that we have, I think, yet to recognize. We've been through this once already in our world of architecture. So when we reverse engineer and change things, we're talking about recreating and find the drawings, changing the drawings, and then changing the physical object. And this is what we see time and time again. Recreate, find the drawings, change the physical object. So we have the desired state, the as-is state, the change kit, and then we work forward. And that's how we actually look at this. So how do we change a building? How do you change an airplane? How do you change a PC? Well, if it's the company's PC, we go for it and see what happens. If it's our own PC, we're very careful about the change that's there. And how do we change a system? Go for it and see what happens. Again, being very straight with everyone is really the approach. We can't reverse engineer and change it because we have nothing there. And finally, the most important thing to us is how do you change the enterprise? And being from southeastern Michigan, of course, most of you know, have little issues here with both large manufacturing companies and also the city of Detroit. They can't fix it. And the alternative is essentially bankruptcy. Now, what we've also learned is how do we speed up change? Once again, if we work outside the IT literature for just a little while, we find out that an organization or a thing goes through 3 levels of maturity as it moves forward. And all of these are different phases, essentially, of the concept of flexibility that we now call agility. We tend to start with what's called make to order. So if we go back 150 years to Henry Ford, we go to Dearborn, Michigan, We walk into Henry's office and say, Hank, build me a horseless carriage. And he says, no problem, I'll have one for you in 6 months. 6 months, because what happens at this particular point is he begins the process of implementation based on what you're saying to them or writing down. If you hear the terms requirements definition and specification, we're really talking about make to order that's there. Please notice the maturing level. Level 1, long lead times, high cost, generally low reliability. And we're suggest to you, unfortunately, that most organizations are in that. And this is why it's difficult to accelerate the change that's there. Level 2 of maturity is called provide from stock. Please notice where we are, level 2. Now, when we come back to this level of maturity, what do we see in the physical world? Let's go back to Henry Ford. Remember the phrase, you can have any color of car that you want as long as it's black. In the enterprise world, when it comes to computer systems, this is the COTS packages, computer off-the-shelf packages. Please notice where we are, maturity level 2. Please recognize I'm not saying that this is bad, I'm positioning. And one of the things we do have to recognize is if we start manipulating that off-the-shelf product, we're actually going back to maturity level 1 and increasing, yes, increasing the complexity. So if we have a package that we're modifying, we're actually adding to the complexity because now we have to keep up with the vendor's changes, the custom changes that we made, and the interfaces. We've actually increased the complexity of the enterprise. Eyes wide open when we make these changes. There is some reduced cost, there is some higher reliability, but there is limited flexibility. And this limited flexibility is what we have to understand. So if any of you are chicken farmers, you know exactly what I'm talking about. If you have a Buick sedan and you're going to go to market and you're a chicken farmer, what you're going to do is put those chickens in the trunk. The last thing you're going to do is try to take that Buick sedan and reverse engineer it into a Toyota pickup truck and then go to market. That's the most ridiculous thing in the world. We have to look at our enterprises and our enterprise systems through those same eyes. In order to change something, it has to be designed for change. Architecture, implementation. The key to enterprise flexibility, enterprise agility, is this concept of assemble to order. Not make to order, assemble to order. The salad bar, the Home Depot, the computer companies has figured out what the independent variables are in the enterprise that's there. And there is no one reference model in Tintin that's going to make this happen, even within the same general area. So the computer manufacturer has essentially in their assemble to order environment, disk drives, keyboards, power supplies, those types of things. The disk drive manufacturer, even though it's the same family of areas, has a different representation. In their assemble to order process, they have read-write heads, they have memory platters, they have frame rails, they have integrated circuits, they have connectors, they have all of these other things that they need. Notice it's a different domain, it's a different environment, it's a different understanding. There is no one model that will solve all of those issues that are there. Very powerful concept that recognizes architecture is different than implementation, and assemble to order is different than make to order. The key phrase here is an almost custom product. It's not a custom product, it's almost. If it's not in the salad bar, we can't do anything with it. So if you take your Midwest salad bar that had iceberg lettuce in it and take it out to the West Coast, everybody knows that nobody on the West Coast of the United States eats iceberg lettuce. As a matter of fact, they'd be horrified. Of course, they eat kale. Now, you have a choice. When you take your salad bar out to the West Coast, you can remove the iceberg lettuce and put the kale in there and everything's going to be fine. Or you can say, you know what? We have a change here, and we have a choice to make. We can modify the salad bar and take the 12-ounce container and make it into two 6-ounce containers and put kale in one and iceberg lettuce in the other. Or we can expand the salad bar because the understanding has changed. Or we can just make some people happy by putting kale in and removing the iceberg lettuce. The last thing that you want to do is to upset everybody by taking the kale and putting it in with the iceberg lettuce, and it becomes mixed greens. And people are sitting there trying to pick things out. Please remember these analogies. And I'm giving you these. They sound a little silly, but they really, really work. And in our enterprises, what we want to do is to sit back for a moment and use the HUM test. That's spelled H-M. Anytime we see something that looks like a miracle, we have to sit back and say, does this make sense? And I'm going to suggest to you, if it doesn't make sense in the physical world, rarely, if ever, is going to make sense in the enterprise world. So the question is, how do we do this in enterprise and enterprise systems? And this comes from essentially the concepts of enterprise architecture, which begins, unfortunately, in our world with the concept of a frame of reference, a framework. And oh my gosh, is this debatable right now? The most common framework we see out there is roll your own. Oh, that's really useful. Just think about the concept of a framework through these eyes. This is the frame of reference, a frame of reference. It is a thinking tool for the concepts of chemistry. Dmitry Mendeleev essentially laid this down. There was no profession of chemistry before Mendeleev came up with the periodic table of the elements. People could call themselves chemists and hint about architects, but there was no such thing. They were alchemists. They were guessing as what is going on. The other thing we have to understand is that for every discipline that we've been able to find to date, there is this many frames of reference. One, or else you can't communicate. You just can't communicate. It's kind of an interesting thing. Now we have to know what a framework is. And from this elements, these are the architectural elements for chemistry. We have multiple sets of compounds, which are implementations. Notice we have architecture and implementations. Fascinating that we see this everywhere. Perhaps we're going to need to see this in enterprise architecture too. Now what's also interesting about this is the number of architectural elements is relatively small in comparison to the number of implementation compounds. So out of one salad bar with 16 containers, you can literally make hundreds of thousands of different combinations of salads. Now, isn't that what our enterprise is looking for? It doesn't know ahead of time what it wants. It can't. We can sit there and pound people and say, we got to do these scenario plans, or we got to do these use cases, or we got to do this XYZ or whatever it is. And you're going to have to sign in blood. And you know what? They'll do that, and we're going to know what happens a few weeks or months later. You can't predict the future. It'd be really great. We can't do that. So there's the example in chemistry. How about this one? This is the musical notes here. Isn't this fascinating? Can you imagine every one of the members of the orchestra having their own frame of reference? That'd be really an interesting set of tunes that come out of there. And from this frame of reference comes these compounds. Now, there are people, here's what's fascinating about this, that know how to take these elements and build these compounds. There are people that know how to execute these compounds, in other words, play the violin, that don't know how to actually compose the music. Isn't that fascinating? Different skills, different approaches. There are people that know how to orchestrate all of the elements in the orchestra, and they may not know how to essentially play any of the instruments. Different skills. We have to look at that as architecture. Architecture skills may not be developed from programmers to analysts to designers to then architects. That is a path, of course, that's possible. But an architectural set of skills may be very different, just like a composer skill may be very different than an implementer skills. One more example here. This is the 26 letters of the English alphabet. Why is this in this order? Well, everybody knows why it's in this order, so we can sing the song. A, B, C, D, E, F, G. It was in a different order. We couldn't sing the song. Of course, that's why it's in that order. Well, what's more fascinating from my perspective as an engineer is I would look at this and say, I would do this quite differently. I would put all the vowels in one place and all the other letters in one place, and I would get rid of this Y, because that is a real problem for me. Y is a sort of. It's sort of this and sort of that. Now, how do I implement that? Okay. Now, I can't, of course, change this particular framework. But once again, this framework leads us to these compounds. Please notice the analogies. Architecture, implementation. architecture, implementation. And this is why it's vital to essentially have a consistent frame of reference in going on. And we would suggest, humbly, and I really mean this, that this should be put to bed by now, which means that we suggest that there is a framework that has yet to be broken, essentially, by anyone else. Now, we're using the scientific hypotheses that says, what is the scientific hypotheses? No one has been able to prove this correct, but nobody has been able to prove it incorrect. And we give credit to that to John Zachman. And John developed this and wrote about it in 1987 is when he actually published this, and it was called a Framework for Information Systems Architecture. And John calls what he's done, and this is very, very important, a taxonomy or an ontology. Ontology is the contemporary phrase that we suggest he is using right now. He doesn't do enterprise architecture. He's an ontologist. And this is one of the misconceptions we see with a framework. A framework doesn't show you how to do things. The periodic table of the elements from Mendeleev does not show you how to build compounds. It says, here's all the things you have to consider to make the compounds that's there. Okay? A salad bar doesn't tell you how to make salads. It says, here's all the elements in the salad bar. A Home Depot environment doesn't tell you how to build a house. It says, here's all the elements in building a house that's there. Architecture framework is different than methodology and implementation. And the other thing John suggests, in the framework, is the stakeholders or transformations. And when we talk about transformation, we're not talking about decompositions. We're talking about different stakeholders, different transformations that give us an understanding of what's going on. And if anybody is interested in the $60,000 word, this comes from the study of reification. How's that? You take that word away with you. Reification. How, boy, oh boy, I've talked about reification today. So there is science behind this. Now, what we've done, for those of you that know who we are a little bit, we have taken John's framework and used the phrase, essentially embellished it. We haven't changed it. Let me make that again. We haven't changed it. What we have here is descriptions of all of the elements. We have guidelines for our practitioners on how to do the transformations, what each one of these models should look like. And we call that the elaboration of the framework that's there. The second thing that we need is the concept of a methodology, a process. And this is what gets us into the architecture and implementation models. So a methodology, we suggest, is dependent upon a framework. I know what it says on the internet there. There are people that declare that our methodology is framework neutral. And all I'm going to say there is use the home test. So our methodology to bake a cake can be used to build a 100-story building. I don't think so. Okay, I'm being ridiculous on purpose. So our methodology is really dependent upon a framework. But a framework can have multiple methodologies. And if we've done anything out there that people have really taken a liking to, it's to build essentially an enterprise architecture methodology, which is just a quick picture of what that is. That's there. Now this leads us to the concept of implementation, which is different than architecture, which is different than frameworks, which is different than methodology. And we're going to suggest that most of the things that we see out there that are referred to as architecture are really implementation models. As a matter of fact, we suggest most organizations that we've had the privilege of working with are actually not doing enterprise architecture, they're doing EITA, Enterprise Information Technology Architecture, because it's around the implementation. Now that's good, but we got to call it what it is. And we see a lot of so-called frames of reference and so-called methodologies that call themselves EA are actually concentrating on the solution, which is very important, but it's a different constituent and it's a different set of representations that are there. Once again, engineering is different than manufacturing that's there. And with this framework, we actually see the elements that you see here on the picture and then the implementation composites. The implementation composites are, for example, the relationship between process and material. In the olden days, we used to call this data flow diagrams. We see the understanding of object models, which is data, method, and an actor. Again, a three-dimensional combination. We see the concept of service orientation, which we suggest, we don't know, because nobody's really defined it precise enough as far as we can tell in these particular areas here, or these 4 cells. So architecture are the elements, the implementations are the composites. Wouldn't it be nice to know what processes are required to support what goals? Absolutely. Wouldn't it be nice to know what processes are required to, what data is required to perform what processes? Absolutely. Wouldn't it be nice to know who's responsible for what processes? Absolutely. Notice the composites. Now here's the problem. Theoretically, let me say this again, theoretically, third time, theoretically, what we have to recognize is there are 684 possibilities. And what you and I have been trying to do in systems is figure out the one model that will solve world hunger. Here it is, we got it. It's data flow diagrams, it's Warnier diagrams, it's object models, it's business process modeling notation, it's scenario planning. We're looking for the one model that will solve all the issues. We're suggesting that it's a lost cause. It's architecture, which has a fixed set of representations, and there's all these implementations. We are not suggesting, let me say this, we are not suggesting that you have to build all 684 possibilities, because we don't even know what some of these look like. But once we have a solid physics-based frame of reference, we can start counting the implementations that are there. So when we talk about implementation models, it's a combination of things. And coming back to the minute-and-a-half test, this is how we represent these to the business people, to the client, to the subject matter experts, whatever you call them. And I'm going to read this to you. And of course, this is a massively simplified version of a diagram of what this actually is. But it has the same characteristics. Of course, for your enterprise, it's a lot bigger. So let me start the clock here, so to speak. What we have here is an understanding of all the processes in our enterprise. Wouldn't it be nice if that's all there were? And we have prepare charters, outfit sailboats, process departures, and process charter returns. These are the process names. In order for us to prepare charters, we need data about sailboats, we need data about maintenance, we need data about preferences, we need data about charter data, and we need data about sales data. That's how we read this. Now, what would we tell our subject matter experts? What they have to do is to essentially verify this. What they have to do is to verify that that sailboat information is actually required to prepare charters and suppliers is not, and they go through this. And that's about a minute and a half, and that gives us the understanding of the composites. Same thing, we look at sailboat information, we can see that it's used across these 4 processes. Please remember this is a teeny tiny real example, but let's look at the power of this thing. What does this tell us also? It says that if we are trying to change sailboat data when we're talking about processing departures, we have to say time out, time out. That information is also used across many other processes. So before you change that, you have to figure out what the effect is on these other ones. What is that telling us? Cause and effect. It gives us the ability to do risk analysis. That's one example. I've got one more implementation model, and then we're going to close out for the day, just to give you an idea. This is one of the most sensitive models that you can build in an enterprise. It's so visual that we have to be very, very careful that it's accurate. This tells us the processes required to meet our goals here. Now, I'm just going to give you a little bit more analysis. What does it say here on this line that says open Australian operations that we don't have any processes? It's suggesting to us that we don't know how to do this. That's why it has to be very sensitive. Now, remember, we're giving just a snapshot of each one of these models. What does it say in this direction? It says that process charter returns are used to support 4 goals. Process departures is there to support 2 goals. What's the initial 0.7, as we joke about, conclusion that we can draw here? What's the initial conclusion? It's essentially, have we been able to, or are we able to essentially declare that these are core competencies? Oh, this is fascinating. Instead of declaring core competencies, we can essentially analyze core competencies. I just want to mention one thing here. I know some of you are leaving because we're at the time right now. We're sending you out a survey link to see if you enjoyed this session and suggestions, and if you'd like to see some others. So if you would like to, it's an anonymous survey. We'd appreciate your feedback as to how you thought the session went and things that you'd like to see, or maybe you don't want to see anymore. We understand that. So just in closing, just 5 more minutes, because we started a little bit late, just 5 more minutes here for those of you that would like to stay with us. These models show us relationships, and these are implementations. And this is what the enterprise wants to manipulate. They want to manipulate this. So what we need is the architectural elements that we can draw from to essentially come up with the implementation composites. And incidentally, the survey link has been sent to you through our chat area. So hopefully you'll be taking a look at that. So architecture models essentially are different than implementation models. And an expanded definition of enterprise architecture would be like this. Enterprise architecture is explicitly describing an organization through a set of independent, non-redundant artifacts, which we call the architecture or engineering models, defining how these artifacts interrelate with each other, and that's the solution and implementation or manufacturing models, and essentially developing a set of prioritized aligned initiatives to move the organization from its as-is state to its desired state. So architecture, enterprise architecture is about 2 things. It's about the architecture models, about the implementation models. In addition to that, there's a difference between frameworks and methodologies. And those 4 things are what we refer to as holistic enterprise architecture. You need a frame of reference, a framework, a methodology, and the recognition of architecture models and implementation models. And with that, we suggest you will have an enterprise architecture that's robust and provides the agility the organization is looking for when coupled with one final thing, assemble to order solution development life cycles. Thank you for your attention today. I hope that this added to your body of knowledge that's there. We ask again that if you can send that survey to us, that would be fantastic, so we can get your feedback, see if you want more of these sessions, if there's an interest to you. And perhaps we'll see you at one of our actual workshops where this is obviously going to be expanded, and you'll be able to practice in our workshops both the architectural representations and the implementations that are there. So what we're talking about is a quick overview of a key concept. Architecture is different than implementation, and those are the 2 models that are there. We thank you for your attention. We know we have time zones all over the world. Some of you are going to take a nap, and some of you are going to have breakfast, some lunch, and some dinner. We really appreciate your time, and hopefully it added to the body of knowledge that's out there on enterprise architecture. Thanks again for your attention. This session has been recorded, and we'll send you a link if you're interested in looking at it, or some of your colleagues to be able to look at it and move forward. We know everybody couldn't be on with us. Thank you again.